In baseball, a batter successfully reaches base between 2 and 3 out of every 10 attempts. The motivation for this project is to see how reasonable it is to aggregate all of a pitcher's pitches throughout his career in order to expose any tendencies that can be used to close the advantage gap between the batter and pitcher. We wanted to keep our analysis very granular, focusing on the analysis we could carry out for one particular pitcher. If we could prove that our analysis gives some intuition for a particular pitcher, whom we choose to have a large enough sample of pitches, then it serves as a proof of concept that our analysis can be carried out to other pitchers as well. The majority of our data was obtained from brooksbaseball.net, a website dedicated for sabermetricians interested in MLB pitching data. After crawling and scraping the site for over a week, we had over 135,000 raw HTML files that contained detailed data for approximately 5 million pitches. We then wrangled the data into CSV files where each file contained all of the pitches for a distinct pitcher and could be easily consumed by the Pandas Python library. We then proceeded by analyzing a pitcher strategy over the course of a game by looking at the occurrence of different pitch types averaged over the pitcher's career. From the pitches that we analyzed, we concluded that there was no significant pitch strategy deployed during the course of a game based strictly on time. The only significant trend amongst all of the pitchers was that there was less fastball-related pitches later in the game, likely due to fatigue.
We looked at 6 batters with the greatest number of pitches seen against Felix Hernandez to determine changes in strategy. Consider Ian Kinsler. Hernandez threw fewer off-speed pitches and many more fastballs to him than usual. One explanation for the change could be Kinsler's poor record against faster pitches and a good history against slower pitches. However, changes for other batters couldn't be explained so easily.
The last part of our analysis was to determine what features contribute the most to a particular type of pitch. The dimension reduction method was based on a random forest approach which attempted to find the most important factors. Ultimately, we found that the batter ID contributed the most to the type of pitch, reinforcing the idea that a pitcher changes strategy based on the batter.